So moving on. We're now considering the two-sample tests, and our first requirement with two-sample tests for the differences in two populations is, are they independent populations or are they paired? And recall here that with the independent populations, we can use our theory based on the probability and difference of random variables. So it's a very, very important starting point to determine if they're independent or paired. Now, in the first example here, we're mounting tires on cars, and we're looking at measurements before and after those tires are mounted. So these are clearly paired or matched. Each car has before and after values for the tires. So this is a paired test, and we would not use our independent tests for this one. The second example, the life expectancy of light bulbs made in two different factories. And for this, if we consider that one of them may be on the North Island and one on the South Island, these are clearly light bulbs being made in two different locations, two different factories. So these would be independent populations. The third of those examples, difference in hardness between two metals. So if we consider one metal which might be a sample of metal that does not contain an alloy, and a second metal which does contain an alloy, like for instance brass and copper, two different metals, then this would be again independent. Those are not related. We're not measuring one sample of metals before and after an alloy is added to it. We're looking at the difference in hardness between two metals, one which does contain an alloy and one which does not. So that would be independent populations. And the final example, the one with, again here, we've got two different motorcycle tires, and we're mounting them on one motorbike, or individual motorbikes. We put one tire on the front, the other on the back. So if we were doing this kind of a test, we'd be looking at randomly selecting which one goes in which position, but they're all related to individual motorcycles. So of course the variability is going to be reduced to the individual variability, and these are clearly paired populations. They are related because it's the same motorcycle, one tire from the front, one tire from the back, across a population which are being measured twice, the same population being measured twice as opposed to two independent populations.